So this video is to explain a little bit about how you build circuits on your breadboard. So this is a breadboard that has had the back of it stripped off, so you can see the metal rails underneath the plastic. So this is where you're normally working, building your circuits, and this is what it looks like underneath. So as you can see, those edge rails are connected by two long strips. So the red and the blue rails are all connected via these two very long strips. In the body of the breadboard, all the little strips of 5 holes are connected together, but separate from the next set of 5 holes. So again, just flipping this over, 5 holes here are connected together electrically, but they're not connected to the next row of 5 holes over, or to the ones over here. So 5 are connected together, and they're not connected to anything else. And again, you can see that here. 5 are connected together, they're not connected to anything else. So your breadboard is going to look more like this. So I've plugged in my board now, so you can see that I've now got power going to the board. I also have a 10 kilo ohm resistor plugged in here and a 200 ohm resistor plugged in here. And you'll notice with both of them, I plugged one end of the resistor into the negative rail of the breadboard, so into the ground wire, this blue rail. So both of them are plugged into ground on one end, and the other end I've plugged into one of these sets of 5 holes over here. So they're not connected to each other over here because they're in separate sets of 5 holes, but I can connect other things here in series with my resistor. And that's what I'm going to do, is I'm going to plug in an LED. Now you have a variety of LEDs in your kit, but you do have a limited number of them, so you don't want to burn them out. So the general rule is that your LED always needs to be hooked up in series with a resistor, or you will burn it out. If you plug in one of these LEDs directly across 5 volts and ground, it will light up and then it will burn out pretty much immediately. So don't do that. You always want it connected in series with a resistor. So which end is the positive end and which end is the negative end? Well, if you haven't played around with the ends of your LED yet, you'll notice that one of these wires is longer than the other wire. So the long wire is the positive end. That's the one that should go to the more positive voltage, and the short leg should go to the more negative voltage. If you have messed with it a little bit, it might be hard to tell which one's longer. You can also look inside the plastic, and in our LEDs, the larger piece of metal is again the positive end. So as I said, I've got a 10,000 ohm resistor here and a 200 ohm resistor here. So I'm going to take this guy, and I want to plug it in series with these. So again, to get this hooked up with, for example, the 10K resistor, I want to plug into the same set of 5 holes over here. So I just make sure that one end of my LED plugs into the same set of 5 holes as this resistor is plugged into. So this one plugs in here, and I just went one down and plugged in my LED there. And then I put the other end over here in the 5 volt rail. Notice if you plug it in backwards, it does not light up. So that's because this is a one-way LED. The current can only flow in one direction. If you plug it in backwards, it just doesn't light up. You do have two-way LEDs in your kit. These are the ones that look white, like this. So if I plug this in series with the 200 ohm resistor, it lights up red, which you maybe can't see too well in the video. And if I then plug it in the opposite way, it lights up green. And this is pretty subtle in the video, but that's green. And if I plug it in the other way, it's now red. So you can sort of see that. The more modern LEDs will light up a lot brighter when you plug them in parallel with a 200 ohm resistor. So you may want to use a 10K resistor just if you're finding that really painfully bright, because then it's not as bright. Note that if you plug in both legs of something to the same set of 5 holes, like I've done here, so there's one set of 5 holes here, and I plugged both ends of the LED into it, this is shorted out, because remember there's a strip of metal underneath the plastic. So there's a strip of metal, the current can go through that. There's no reason for the current to come up through this high resistance path. So even if I hooked up 5 volts here and ground on the other side, it would just be a short straight from 5 volts to ground. No current would pass through the LED. It would not light up, just because I've shorted it out underneath the plastic. So when you do plug things in, you always need to put both legs into different sets of 5 holes. So for example, I could take a small piece of wire, attach this to 5 volts, take a resistor, attach it to ground, and this guy would now light up because both legs are plugged into different sets of 5 holes on the breadboard. So feel free to play with your equipment, just be really careful to always plug in the LEDs in series with a resistor to keep them from burning out. And your rule of thumb should be, if you smell smoke, unplug right away. And it's better to unplug your USB cable than the components themselves because the components may have heated up and you might burn your fingers if you grab one of those. So unplug your USB. When something is overheating, that usually just means that you've got too much current going directly from 5 volts to ground. Maybe you've got something shorted out. But in general, if you smell smoke, unplug it as quickly as you can.